Hello, welcome to today's lesson. Today we're going to be doing an introduction to statistics. What is statistics? What is statistics? Statistics involves the collection, organization, and analysis of observations called data. Well, what is data? Data represents individual observations to which we can assign some numerical value or categorize in some way that identifies an attribute. So we take data and we're going to, first we have to collect it, then organize it, and then we're going to analyze it. That's what statistics is. Continuing on with statistics here, we have to know what a population is. A population is the set from which the data is collected. Well, if we have a population of people, we want to take a sample, a smaller subset of that population. A sample is a subset of the population. We can't possibly interview or get data from everybody in the population, but we can take a sample which represents the population, hopefully. What is sampling? Sampling is the process of gathering data. Statistical inference is what we want to make once we have our data from our sample. The characteristics of a sample, that's the small group, are used to draw conclusions about the population. Obviously, you can only draw conclusions about the population if the sample is representative of the population. So, to ensure that this is the case, or to try to make this the case, we do something called random sampling, so that everybody in the population, theoretically, has an equal opportunity to be in the sample, so that the population is roughly the same as the sample. This diagram shows the sampling process in a nutshell. We have a population. Let's say that's the population of all students at the school. We sample, we stand in the hallway in a central location that we know all students pass by, and we ask them, how many times do you brush your teeth per day? We take 100 out of the population of, say, 1,000 students, we take 100. And now what we have to do is analyze our data. We might want to take the average. So we get an average, after we analyze, we get an average that 1.4 times the students brush their teeth. So then if the sample is like the population, if we've done some random sampling and we make a conclusion that the sample represents the population, we can make an inference about the population saying that, well, in the school as a whole, all students brush their teeth about 1.4 times per day. In our study of statistics, let's talk about the different types of data we can have. We could have numerical data, which would be described as quantitative. In other words, we can put a number to it. If you're doing heights, for example, our heights could be measured in centimeters or millimeters or fractions of millimeters, and you can keep on going. The data is continuous. It can be measured. Another type of data would be categorical data, which would be qualitative. What is the quality of your hair? It's blonde, or it's black, or it's brown. Hair color can be put in different categories and counted. Discrete data is counted. Continuous data is measured. Let's talk now about a frequency diagram. The objective of a frequency diagram is to show the distribution of data as clearly as possible. For example, if we're given this data here, here are heights of people in centimeters. Notice the class goes from 148 to 150, but that would really mean 147.5 to 150.5. Similarly, 151 to 153 goes from 150.5 to 153.5. You get 0.5 on either end of these. If I'm counting the number of people, I would put the tally mark as I asked them how tall they were in each category, and then summarize with one number for frequency. Well, what I've drawn below here is a picture of this. It's called a histogram. A histogram measures frequency. Notice on the y-axis I have frequency, and I'm looking at height, so I put height on the x-axis. Well, the middle of this interval from 148 to 150 is 149. Similarly, the middle of this interval is 152. I draw my histogram like this. One of the things that's important to remember about a histogram is it's not the height of the bar that matters, it's the area included within each bar. We can see that the area is base times height. Why do I mention that? Well, with a histogram you don't have to have equal sized bars. In the case of a histogram, often at either extreme end, for very short people or very tall people, in this example, we might have bars of different lengths. For example, I might show if there's 3 people who are taller than, say, 159, I might show it like this and just say taller than 159, like that. And so there'd be 3 people in this category, but we could tell that only because we take the area of this particular bar and we see that it is 3.